Well, now again we are continuing with the portion of kinematics. As earlier we have discussed many concepts in the kinematics. Now, in the further proceedings of the kinematics, normally kinematics is concerned with motion in straight line as well as motion in plane. Our discussion is continuing right from motion in straight line or the rectilinear motion. Now, in this context, we are now continuing with the portion that is motion under gravity. That is, when we use the term motion under gravity, either we are throwing the particle above the surface of Earth or otherwise the body is coming towards the Earth. So, motion under gravity is basically concerned with, that is, under what circumstances we use the value of acceleration due to gravity g. Whenever body is moving horizontally, we find that body is uniformly accelerated, but when it is thrown up or coming down, we have to consider the acceleration due to gravity. Acceleration due to gravity instead of A. So our discussion is motion under gravity. Either the body is thrown up or the body is coming down. When the body is ascending, the value of g is taken as negative. When the body is coming down, that is descending, the value of g must be taken as positive. These facts are to be applied in motion under gravity. Now, the very first thing is the most important example of motion in a straight line with constant acceleration is the motion under gravity. In case of motion under gravity, we have certain basic assumptions. The very first thing we assume that acceleration is always constant. That is, the value of g is taken as 9.8 meters per second square. But in any question, if it is not given, then we take it approximation, which is found to be 10 meters per second square. Now the acceleration is constant. A is equal to g is equal to 9.8 meters per second square and directed vertically downward. The second thing to be remembered is the motion is assumed to be in vacuum, because when motion is in vacuum, the air resistance is neglected. So we have written here, that is viscous force or the thrust of the medium, that is air, has no effect on the motion. One of the very important thing is that if we take a ball made up of steel and cotton of the same amount, that is 1 kilogram ball of steel and 1 kilogram cotton. Cotton has more volume, whereas steel has less volume. So when they are released from the same height in vacuum, we find that they come with the same rapidity because there is no air resistance or there will be no viscous force. But if the same two bodies are dropped in air medium, we will find that steel ball will touch the ground earlier as compared to cotton bale, because cotton bale has more air resistance, so it will come gradually towards the ground. A body falling freely under gravity. So when the body is coming down, falling freely under gravity, taking initial position as origin and downward direction of the motion as positive, we have u0, that is body starts from rest. A will be equal to plus g, that is acceleration is equal to acceleration due to gravity in the direction of motion. So if the body acquires velocity v after falling a distance h in time t, then equations of motion will be, first equation is v is equal to u plus at, but because the body is coming down, so it can be written as u plus gt. Similarly, s is equal to ut plus half at square. Because the body is coming down, so a will be replaced by g and equation can become ut plus half gt square. Similarly, v square is equal to u square plus 2as, but being the body is coming down, falling freely under gravity, so a can be replaced by g and the function can be written as v square is equal to u square plus d2gs. Now, all these equations are reduced. Here we have taken initial velocity as 0. So the numbers will become v is equal to gt, h is equal to half gt square and v square will be equal to 2gh. Now, like in the third equation, we are interested to find height. It will be v square over 2g provided that initial velocity is 0. Similarly, if we take up the first equation, that is V is equal to GT, and we are interested to find time. The ratio of V and G will give the value of time because U is 0. Similarly, in the second equation, that is H is equal to half GT square, we will find that T square will be 2H over G, or T will be taken the square root, that is 2H over G square root, but this equation will be valid when U is equal to 0. These equations can be used to solve most of the problems of the freely falling body. The point to remember that in the horizontal motion, the equations of uniformly accelerated motion will be V is equal to U plus AT, S is equal to UT plus half AT square, and 2AS will be equal to V square minus U square. But in the vertical motion, when the body is falling freely, then if the body is coming down, G will be positive, and if the body is going up, G will be taken as negative. That is, in all the equations, we have to replace A with either G or minus G, depending upon whether body is going up or body is coming down. Now, three graphs are indicated. The first graph is HT graph, in which it is depicted that H is taken on y-axis, T is taken on x-axis, and we are finding that the nature of graph is straight line up to some extent, that as the time is increasing, the height is increasing, and at a certain point when the time becomes constant and height is increasing, the curve is being indicated going upwards. Similarly, in the second graph, it is a graph between velocity and time, and it is depicting the tangent of the graph, that is tangent theta will be equal to acceleration due to gravity. This graph is basically the slope of the particle or slope of the velocity. In the third graph, it is a graph between acceleration due to gravity and time. Now, if the body is dropped from height h and in time t, it has fallen a distance h, small h, from its initial position, the height of the body from the ground will be h minus h, and small h can be estimated by function ut plus half gt square, but u will be taken as 0 because body started from rest. Hence, the equation can be written as half gt square. Now, in the second point, as h is equal to half gt square, that indicates that h is proportional to t square provided that g is constant. So obviously g is constant and uniform. It is uniformly accelerated body. Distance fallen in time t, 2t, 3t will be given in the ratio 1 square, 2 square, 3 square, etc. That is the square of integers. So if you check the equation, h is equal to half gt square, half g is constant. So t can be replaced by simply t, 2t, 3t, and we'll get the numbers as 1 square, 2 square, 3 square, and so on. Now, the third point is the distance fallen in the nth second. So what exactly we mean by the nth second? Nth second means distance covered by the body in a particular second. So, first of all, we have to find distance covered by the body in n seconds, and then we have to find the distance covered in n minus 1 seconds, and then we take the difference of the two. The equation to be used for them will be s is equal to ut plus half gt square, because it is a vertical fall. So for hn, we will put the value un plus half gn square, and for hn minus 1, wherever we have used n will be replaced by n minus 1, and after calculation, the net result will come half g into 2n minus 1. So the distance fallen in the first second, third second, etc. will be in the ratio of 1:3:5, that is the odd integers only. Now, we will go through with an example. A body is released from height and falls freely towards the earth. When we say falls freely, we have to consider the value of g, and if the value of g is not given, we have to take it approximately 10 meters per second square. But in our question, the value of g is given as 9.8 meters per second square. So this value is to be considered during calculation. Now, next point is exactly 1 second later, another body is released. What is the distance between the two bodies after 2 seconds after the release of the second body? The value of g is being provided. Now, in order to solve the question, the second body falls for 2 seconds. So height will be h2 and it is calculated by function half gt square, and for t we will compute 2 square. So it will become half g into 2 square, equation number 1. While first has fallen for 2 plus 1, that is 3 seconds. So again we are going to use the equation, that is height h1, that is half gt square, half g into 3 square. Now we have got two equations. So separation between the two bodies after 2 seconds, that is given by d, and d is h1 minus h2. Now we compute the values from equation number 1 and 2, and we will come to conclusion that the value of distance, that will be 24.5 meters. So h1 minus h2 will be 24.5 meters.